In this lesson, we will use a number line and multiplication chart to find multiples of a one-digit number. In the previous lesson, students learned that a multiple is a product of a given whole number and any other whole number. We also learned how to find multiples using counters. However, depending on the context, sometimes it is advantageous to use a number line to find multiples. For example, look at the following problem. On Jamar's bike ride, he stops to rest at the end of every 4 miles. At what distances from his starting point will he stop? I can tell we are looking for multiples of 4 because he stops every 4 miles. Since this is a linear problem, a number line is a great way to model the multiples. To find multiples on a number line, always begin at 0. 0 is the starting point, not one of the rest stops. Let's begin at our starting point, 0. We are going to jump lengths of 4 because he stops every 4 miles. One jump of 4 is 1 times 4, which equals 4. 2 jumps of 4 is 2 times 4, which equals 8. 3 jumps, or multiples of 4, is 3 times 4, which is 12. 4 multiples, or jumps of 4, is 4 times 4, or 16. And 5 multiples of 4 is 20. As before, we could continue, but we will stop there. To answer the question, I could say that Jamar could stop at mile 4, 8, 12, 16, 20, and so on. Now let's compare a multiplication chart to our number line to see how we could use that to find multiples of a number. To use a multiplication chart to solve this problem, I would choose my multiple on the top row, in this case 4. Going down the column, the multiples are listed up to 10 times the given number. The numbers on the left side of the chart are how many jumps, or multiples, on the number line. Remember the first jump was for a length of 4? On the chart, 1 times 4 shows the multiple 4. When we jumped 2 multiples, we landed on 8. Continue with 3 jumps for 12. As before, we could continue. As always, I'm going to look for patterns of multiples of 4. Let's shade in a hundreds chart to show all the multiples of 4. Your child will probably first notice the spatial relationship, where there are 3 boxes between numbers and they fall in certain columns. Encourage them to keep looking and notice the digits of the numbers and connections to previous knowledge. You may notice that 1/4 of the numbers between 1 and 100 are multiples of 4. Also, all the multiples end with 0, 2, 4, 6, or 8. This also means that all the multiples of 4 are also multiples of 2. Now let's change the original problem to say that Jamar now rides 6 miles before he stops. And instead of just asking where he could stop, what if I asked you to determine if he would stop at 15 miles? What about 18 miles? Since he stops every 6 miles, we are now looking for multiples of 6. Let's again begin with our number line. Starting at 0, we are jumping lengths of 6 to see if we will land on 15. Jumping once, 1 times 6 is 6. Jumping twice, 2 times 6 is 12. And jumping 3 times 6 is 18. I can see that I did not land on 15, so I know that 15 is not a multiple of 6. However, I did land on 18, so I know that 18 is a multiple of 6. If I had instead used my multiplication chart, I would have found 6 at the top of the chart, and going down the column, I can see that there is not a 15 in the list of multiples going down. So this also shows that 15 is not a multiple of 6. However, I do see 18. To find how many multiples of 6 this is, I would look on the left side and see that 18 is 3 multiples of 6. Remember that each time you find multiples of a given number to stop and look for patterns to help recognize multiples of that number later. Our goal today was to discover multiples of a one-digit number. We did this by using number lines and multiplication charts to find the multiples and look for patterns.